Hello, dear students. Good morning to one and all. So, welcome back to the chemistry class. In the last class, we have discussed the first paper. I think remaining problems you have solved. So, today we are going to discuss another paper which I already sent you in the group. Solution. I think maximum questions as already we have discussed. So, just recall those concepts. The first question: which of the following changes with increasing temperature? They have given some concentration units. First one, molarity. Second, molarity. Third, percentage, weight by volume percent, and normality. Molarity, normality, and percentage, weight by volume percentage. Among these four options, which of these are temperature dependent? That is the question. As you know that already, the concentration units which are dependent on the volume, which changes with the temperature. Because as the temperature changes, increase or decrease, expansion, temperature increases, expansion of volume takes place. So when volume increases, concentration decreases. So here, molarity, by definition, you know that it is independent on its volume, because the definition, number of moles divided by weight of solvent you have taken. So therefore, it is temperature independent. Molarity, it depends on the volume, weight by volume percent, and normality. So here, almost these three are dependent, and the first molarity is independent. So therefore, you can select the options which containing all these three options. So third option, 2, 3, and 4. That is molarity, volume percent, and normality. It is dependent on temperature. First, second question. The second question is 200 ml of 0.1 molar barium hydroxide solution is neutralized by 100 ml of sulfuric acid solution. Then what is the normality of sulfuric acid? The reaction is barium hydroxide reacting with sulfuric acid. Both are neutralized, its volume and normality is given for barium hydroxide. Whereas for sulfuric acid, we need to find the normality. For neutralization reactions, as we know that, for neutralization reaction, normality N1 V1 is equals to N2 V2. So here it is given 200 ml of M/10 barium hydroxide. First one for barium hydroxide, second for sulfuric acid. So this barium hydroxide is given 200 ml of, its volume is given 200 ml with M/10. So that is equals to 100 ml of its normality is equal to question. Look at this. Here normality, but in this case is molarity. The terms they are given different, normality and molarity. Either you convert this in normality or this term into molarity. As we know that normality is equals to molarity into valence factor. We have this formula also. So just you can substitute in case of molarity I am converting into normality 200 into 1 by 10. Molarity is nothing but normality. Molarity into molarity is what? Into valence factor. For variable hydroxide valence factor is 2 is equals to 100 into normality. So now 101 is a 102 is a 2 is a 4, 4 by 10. 4 by 10 is equals to normality. So answer normality is equals to 0.4. That is the second. Normality is equals to 0.4 mm. Second option. Third option. Third option. The mass of urea required in making 2.5 kg of 0.25 molar aqueous solution. 2.5 molar aqueous solution. Mass of urea required in making 2.5 kg of 0.2 molar aqueous solution. Molality. Actually, it's molar. It is molar. We just make it change molar. If molar, we require the volume. No problem. Even molar also you can calculate molar or molar. If it is molar, we require volume. They have given 2.5 kg of water solution. Water density is 1, so as it is 2.5 can take. So here, molality, number of moles of solute by weight of solvent into 1000. If it is in grams, number of moles is nothing but given mass divided by molar mass. Mass of urea is 60. I don't know the given mass that I want to find here. Weight of solvent is 2.5 kg. That means we need to multiply by this, or else this is converting into grams into 1000. That is equal to molarity is equal to 2.5. So therefore, so this I can start out same as it is 2.5 kg. X is equals to, so here X is equals to 0.25 into 60 into 2.5. Therefore, the value of X is 60 into 1 by 4. 60 into 1 by 4 is nothing but it is 15. 15 into 2, 15 to 30 plus 7, that's 7.5. Cross check, verify the answer. 0.25 is nothing but 1 by 4. 1 by 4 into 60, that is 15. 15 to 30, 15.5, 7.5. This is the next question. Vapor pressure of pure benzene at certain temperature is given. Vapor pressure of pure benzene P0 for benzene C6 and 6 at certain temperature it is given. But a non-volatile, non-electrolyte solid which weight of solvent is given 0.5 gram when added to 39 gram of benzene. 39 gram of benzene. Molar mass of solute is equal to molar mass of solute, molar mass of solvent. Solvent is benzene. Benzene molar mass 78. Then the vapor pressure of solution is 0.845. What is the molar mass of solvent? Molar mass of solute. So molar mass AP is equals to question mark. As we know that related to working vapor pressure. delta P by P naught is equals to XP. XP is nothing but NB by NA. NB is nothing but given mass by molar mass divided by Na, that can be written as NA by WA. Its ratio I am writing like this. So the difference delta P 0.850 minus 0.845 divided by 0.850 is equals to WB 2 gram, MB I don't know, molar mass 78 by 39. 78 weight of solvent is 39. Correct? Sorry, it is 0.551. 39 ones are 2 2 into 0.5, that is 1 by MB. The difference is 850 minus 845 is 0. 0.850 is equals to 1 by MB. Or else MB is equals to 0.850 divided by 0.005. So 850 divided by 850 divided by 125. You will get to 170. Answer 170 plus MB is equals to, the answer is 170. Molar mass absolute is 170. Molar mass absolute is 170. Next question. The osmotic pressure of a solution is prepared by osmotic pressure of a solution. That means pi is equal to question mark. Which is prepared by, how it is prepared? By dissolving 25 milligrams of potassium sulfate in 2 liters of water. Next problem. Osmotic pressure formula pi is equals to WRT by MV. Pi I want to calculate. So pi is equals to W, weight of solvent. How much it is given? 25 milligram. 25 milligram. R value 8.74. Sorry. R values. Look at the options. In options, they have given atmosphere. So therefore, R value in radium 0.0821. Temperature 25 degree. That is 298. Molar mass. Here it is okay. K2SO4. Potassium sulfate 39 into 2. 78 40 into 2 80 minus 78 plus 32 plus 64. Number 174. 174 into volume. Volume is 2 liters. Let's simplify and find the value. Pi is equals to, yes, simplify this and find the value. Find out the value. Verify. What is the answer? That is 1.76. 1.76. Once you verify after into 10 power minus 3 atm. Osmotic pressure of this solution is 1.76. Next question. The mass of a non-volatile solute, which having the molar mass 40, which should be dissolved in 114 gram of octane to reduce its vapor pressure to 80%. To reduce its vapor pressure to 80%, to reduce its vapor pressure by 80%. There is a difference between these two words. Okay. So here's next problem. Mass of a So that is WB is equals to question mark. MB is given in bracket, it is 40. Added to solvent octane is given 114 gram of octane. Octane C8H8. So the formula is known. Molar mass also you can find out. Its molar mass is also 114. Now the question is vapor pressure. Let us consider initial vapor pressure. P0 pure form is 100. Pure form is 100. The vapor pressure is reduces to 80%. That means final pressure is 80. Final is 80. To reduce its vapor pressure to 80%, final is 80. To reduce its vapor pressure by 80%, then the final is 20. Because 80% is reduced. It is reduced by 80%, then remaining is 20. So here, reduce its vapor pressure to 80%. So I will, therefore, delta P is, we have this formula delta P by V is equals to, so the formula WB can be MA WB. Delta P is 20 by 100. WB question mark as it is. WB is equal to question mark. MB is 40. MA 114 and this is also 114. So therefore, WB is equals to another end 80 200 divided by 100. WB is equals to 8 grams. 8 grams. So first option, nearer answer. Second is 15, 20, 3.2, 10. So near answer, you can select option A. Next question. 7. Boiling point of water at 750 is given. Boiling point at 750 level is given. Molar elevations is also given. How much glucose is to be added so that water. Okay. Boiling point PB is 96.63 at 750 ml. This is given the boiling point of water. Next problem. Okay. Next problem. 96.63 at 750 is given. A boiling point of water. Next question. How much sucrose is to be added to 500 grams of water such that the water boils? This is given, the not add. This is it is 100. 100. How much sugar is added? WB is equal to question mark. WA is equal to 500 grams. Sucrose. MA is equal to 342. MA rate of water WB we want to find. So delta DB is equal to KB into M. M is the number of moles. V1 mass by molar mass divided by weight of solvent into. This is the formula. Delta T difference. delta T. The difference is 100 minus 96 is 4.37. 3.37. 3.37 is equal. KB value is given. KB is 0.52. 0.52. WB question mark into 1000. 200. MB read 42. WB 500. 500 ones are 2. Here 270, 170. Right? So WB is equals to 3.37 into 171 divided by 0.5. So therefore WB is equals to question. Solve this. This is 171 into 3 times divided by 5 means 1108 last check. Yes, 1108 grams. The next problem. At 80 degree, the vapor pressure of pure liquid A, vapor pressure of pure liquid is 500, whereas vapor pressure of pure liquid B is, I think, 1000 is given. If the mixture of solutions A and B boils at 1 atmosphere, mixture boils at the boiling point is given, it's related with the vapor pressure. So the total vapor pressure is given at 1 atmosphere, that is nothing but 760 M. So according to the Newton's law, P is equals to PA plus P. So total P is nothing but P naught A into X. P naught B into XB. I want to calculate XA and XB. So P is 760. 520 into XA plus 1000 into, in place of XB shall I write 1 minus XA? So it is 760, 520 XA plus 1000 minus 1000 XA. So here is this 1000 XA minus 520 XA is equals to 1000 minus 760. 480 XA is equals to 240. XA is equals to 241, so that is 1 by 2. XA is equals to 0.2. When XA is equal to 0.5, XB is also 0.1. The mole fraction of A in the mixture is 50%. 50. The next question. Next. 0.5 molar aqueous solution of each. Molarity is 0.5 molar. KCl, FeCl2, FeCl3. Have the freezing temperature T1, T2, T. Freezing points. These are given Tm. Freezing points are given. Which of the following are described? So here, as we know that, as we can derive this, Tf is inversely proportional to delta Tf and Tb directly proportional to delta Tb. This delta Tf is directly proportional to m into I, or directly proportional to m, or directly proportional to I. Concentration is same, so it depends upon the number of ions It's split up to give 2 ions, it's split up to give 3 ions, it's split up to give 4 ions. So greater the value of I, more will be the delta TF, lesser will be this value. I value is 4. Delta TF is more in this case, TF is less. So T3 is lesser than T2, T1 is less. This is the correct order. T3 less than T2 less than T1. First option. T1 is greater than T1 is greater than T2, T2 is greater than T3. Same. First option. Next question. Which of the following is correct for the reaction? Which of the following is correct for the reaction? 3x gives rise to x3. x3 gives rise to 3x. Three molecules or 3 atoms are associated, joined, and here it is dissociation. Association, dissociation. They have given alpha equation, degree of dissociation or degree of association. So in case of association, alpha value is given by alpha is equals to I minus 1 divided by 1 by n minus 1, where n is the number of associated molecules. In case of dissociation, I minus 1 by n minus 1. If you are confusing with the same n terms, you can use m, number of ions. So this is the formula we have. In this case, n is equal to 3. N is equal to 3. Let us substitute n is equal to 3. And this can be written as 1 minus I, 1 minus 1 by n. So if n is equal to 3, 1 minus I divided by 1 minus 1 by 3. So that is 3 minus 1, 2 by 3. This becomes 2 by 3. 1 minus I, 2 by 3. That can be multiplied here. So therefore alpha is equals to 3 by 2, 1 minus I. Alpha is equals to 3 by 2, 1 minus I. Yes, first option 3 by 2, 1 minus I. Because this is the formula for degree of, this is degree of association, this is degree of association, DOD. Next question. Aluminum phosphate is 100% ionized in 0.01 molar solution. Hence, delta Tb by Kb is given by aluminum phosphate. Aluminum phosphate. Both having a charge 3, so therefore aluminum phosphate. When it's split up, it's used 2 ions. Al3O4. For this, delta Tb is equals to the formula Kb into m into I. They are asking delta Tb by Kb is equal to question mark. So that is nothing but m into I. M is given 0.01. So how many ions are present? 2 ions. So therefore this value is 0.02. Direct formula 0.02. The next question. Which of the following forms maximum boiling azeotropes? Maximum boiling azeotropes is nothing but maximum boiling. That means more amount of temperature is required in order to boil. That means they are having strong force of attractions. So as expected from ideal solutions, the interactions is more than that. So more than that is nothing but it is negative deviations, we can say. Negative deviation. This is possible when there is an intermolecular interactions increased when the solutions are mixed. Which of the following forms maximum volume acidosis? That means you need to check the pair of liquid should interact and some hydrogen bonding or some interactions are begins in that. Benzene, toluene is the ideal solution. Acetone and chloroform, hydrogen bond takes place in this, it is a negative deviation. Negative deviation means vapor pressure decrease, more heat is required to increase. So therefore, it forms maximum volume. Second option, acetone and chloroform. And the rest, it do not, which are they are asking the maximum volume. Therefore, negative deviation, second option. Molarity of pure water, of 55.56. How? Pure water, 1000 bar. Molarity of pure water. Mass of water is 18. Molar mass is 18. Mass is 1 kg. So for pure water, it is 55.55. Molarity of pure water. 55.55. 55.6. Next question. Mole fraction of glycerin in a solution of 36 gram of water, 46 gram of glycerin. Mole fraction, they are asking again simple concept. Mole fraction, the next problem it is 14. Mole fraction of solute is equal to question mark. Here glycerin, solvent, number of moles of water, 36 gram of water, that is glycerin. How much is 46 gram? Molar mass is, I think, is 92. It is 0.5. So mole fraction of B is equals to 0.5 divided by 0.5 plus 2. It's 0.5 divided by 2.5. 5 by 25, 1.5, 1.5 is 0.2. Mole fraction is 0.2. So it's a third option. The next question. How much volume of 3 molar sulfuric acid is required to make 3 molar sulfuric acid is volume is equal to question mark. Okay. 1 liter of 1 molar. 1 liter. Okay. M1 is equal to M2 V2, therefore V is equal to 1 by 3. 1 by 3 is nothing but 0.33. Since they are given it is in liter, 2.333 liters, and you can write 333.3. Okay. Can you solve the remaining problems? Right. To go through the remaining problems, if any doubts, we'll discuss. If we have the doubts, we'll discuss. Okay. Go through the remaining problems. In the next class, we'll start the next topic, electrochemistry.